Hi, this is our first factoring lesson of the year, and I'm going to have several factoring lessons that we're going to do. And so we're going to spend a good amount of time on factoring this year. So we're going to spend some time now, and then we'll revisit it later in the year as well. So factoring is something you should have done in Algebra 1. I may present the information a little bit differently than your Algebra 1 teacher did, but you should have a decent recollection of it, hopefully. And then factoring is something that you do in all of your other math classes. So hopefully if you get a good understanding of it now, if you take Algebra 2 next year, it will make your lives so much easier. So this is what it looks like when something is factored. This is what it looks like when something is not factored. So when something is factored, you're going to see parentheses. You may only see one set of parentheses. You may see two sets of parentheses, but this is what it looks like when something's factored. Okay. So we have this factoring flowchart to help us figure out what kind of problem it is we're looking at, because there's a bunch of different ways to factor. Okay, so your first rule of factoring is to always look for the greatest common factor, known as the GCF. Does GCF sound familiar? Greatest common factor. That's going to be the very first thing that we look for in every single problem. Okay, and then after that, we'll look to see if the problem has 2 terms, 3 terms, or 4 terms. And I'm going to explain this chart as I go through all the factoring lessons. Let's start off with the GCF. Okay, so I'm going to go to the next page. All right, first I'm not going to factor, I'm just going to practice finding the GCF. So the greatest common factor is the greatest factor that divides evenly into each term of an expression. So for example, if I was to try to find the GCF of this, first I start by looking at the constants, 4, 12, and 8. And I'm trying to figure out what's the greatest number that can divide into 4, that also can divide into 12, and that also can divide into 8. I'm looking for the greatest number that can divide into 4, 12, and 8. And some of you will know this in an instant, and unfortunately others will not know it in an instant and may not know how anybody ever got the answer. So the more you know your multiplication facts, the easier this is. So I will say that up front. If you're really good with your multiplication facts, factoring will be pretty easy for you. If you struggle with your multiplication facts, then this will be a little bit harder. Doable, but harder. Okay, so do you know what the greatest number is that can divide into 4, 12, and 8? It's a 4. Now, I'm going to explain this in a different way in case you had no idea. So to think about all the numbers that can go into 4, you think about the multiples of 4. You start with 1, and you ask yourself, 1 times what makes 4? Well, 4. Then you go to 2. 2 times what makes 4? 2. Well, I already have 2 in the list. And then you go to 3. Does 3 times anything make 4? No. And then you go to 4. But I already have 4 in the list. These are the things that can divide into 4. Let's think about the things that can divide into 12. So you start with 1. So 1 times 12 makes 12. Then you go to 2. 2 times 6 makes 12. Then you go to 3. 3 times 4 makes 12. And then 5 can't go into 12. And then you're to your 6. So these are all the numbers that can divide into 12 evenly. Factors of 8. So 1 times 8 is 8. Then you go to 2. 2 times 4 is 8. Then you go to 3. But 3 times nothing will make 8. And then you're to your next number, which is a 4. So now you've got them all. So these are all the numbers that can divide into 8. So then you look to see, well, what's the greatest number that they all had in the list? Well, all of them had a 4 in the list. So that's why 4 is the GCF of a 4, 12, and 8. Now, some of you won't need to write out your factors to figure it out. Some of you will just know, but some of you may have to do this. Okay, now we need to look at the variables. All right, so this one has 3 x's, 1, 2, 3. This one has 2 x's, 1, 2, and this one has 1. You're looking for the greatest number of x's they all have in common. Do all of them have 3 x's in their list? No. Do all of them have 2 x's in their list? No. But do all of them have 1 x in their list? Yes. So the greatest amount of x's that they all have is they all have 1. So think about these words, greatest common factor. It has to be the greatest amount of x's that they all have in common. And they didn't all have 2 x's, and they didn't all have 3 x's. Okay, so first, in the first little section, I just want to find the GCF. I'm not going to factor it just yet. Okay, so looking at number 1, let's start with just the leading coefficients. So 5 and 10. So I'm looking for the greatest number that can divide into 5 and also divide into 10. And do you know what it is? It's a 5. 5 is the greatest number that can divide into 5 and also divide into 10. Okay, now let's look at the V's. This one has 5. 1, 2, 3, 4, 5. This one has 3. 1, 2, 3. What's the greatest amount of V's they both have in their list? They both have 3 V's in their list, so you write that as V cubed, and that is the GCF. Now, one thing I do want to say, this number out here, the greatest common factor, it can never be bigger than whatever the smaller number is. That's because nothing bigger than 5 can divide into 5. So this number can never be bigger than whatever the smaller number is. Okay, let's look at the next one. We'll start with the leading coefficients, 3 and 18. I'm looking for the greatest number that can divide into 3 and also divide into 18. So if it were me, if I know it can't be bigger than the smaller number, see if the smaller number works. Can 3 go into 3? Yeah. Can 3 go into 18? Yeah. Okay, so that is the greatest common factor between a 3 and an 18. Now let's look at t's. Do they both have t's? No, they don't both have t's, so they don't have any in common. So this time our GCF is just a number. Okay, sometimes the GCF is just a number, sometimes it's just a variable, and sometimes it's a combination of the two. Okay, looking at this one, I'm looking at 4, 2, and 6. The greatest number that can divide into 4, divide into 2, and also divide into 6. So try starting with your smallest number, since nothing bigger can go into that. And see, can 2 go into 4? Can 2 go into 2? Can 2 go into 6? It sure can. So that means 2 is the greatest common factor. Now, do they all have B's? They do. This one has 3. This one has 2. And this one has 1. So what's the greatest amount of B's they all have in common? They all have 1 B in common. So 2B would be our GCF. Okay, let's look at this next one here. So 6, 24, and 18. I'm looking for the greatest number that can divide into 6, divide into 24, and divide into 18. So start with your smallest number and see if it works. Can 6 go into 6? Of course it can. Can 6 divide into 24? Yep. Can 6 divide into 18? Yep. Now, this doesn't mean that whatever the smallest number is always the GCF. It has been in all of these examples, but that doesn't have to be the case. Okay, for example, well, I've got one down below. I'll show you. Okay, now let's look at x's. This one has 6. 1, 2, 3, 4, 5, 6. This one has 5. 1, 2, 3, 4, 5. And this one has 3. What's the greatest amount of x's they all have in their list? They all have 3 x's in their list. So 6x cubed would be our GCF. Now, have you noticed anything about the exponent on the variable that has happened for all of the problems? Whatever the smallest variable is, whatever the smallest exponent is, that's always what's here. The smallest exponent on this one was a 1. That's why we only have 1b out here. The smallest exponent of the v's was the 3, and then we have 3 here. So As long as they both have the variable, whatever the smallest exponent is, that will be the greatest amount that both of them possess. Okay, now we're going to factor. So we're going to figure out the GCF, that's this guy, like we've been doing, but then we're going to build parentheses behind it and figure out what to put in the parentheses. So when you distribute, you take your GCF times this, your GCF times this, your GCF times this, you get the original problem back. Okay, so let's just try. All right, so this is an example of when the smallest number is not the GCF. Okay, so looking at this problem, I'm going to start with the 8 and 12. Do you know what the greatest number is that can divide into 8 and 12? Now, if you start with the smallest number, 8, 8 can go into 8, but can 8 divide into 12? Nope. So this time the smallest number is not the GCF. Okay, so we have to think of something smaller than 8 that can go into an 8 and go into a 12. And what is it? 4. Now, what's the greatest amount of x's that they both have? 1. This one has 2. This one has 1. So the greatest amount that they both possess is 1. And remember, as long as they both have an x, whatever the smallest exponent is, that will be what you can take out. So that's why I could only take out 1. All right, every time you figure out there's a GCF, you build one set of parentheses behind it. Now your mission is to figure out what's going to go in the parentheses, so when you distribute, 4x times this makes that, and 4x times this makes that. Okay, so what could you multiply 4 with to get an 8? A 2. And what could you multiply an x with to get an x squared? An x. Okay, now let's get the guy in the back. What could you multiply a 4 with to get a negative 12? A negative 3. And you don't need to multiply x with anything to get an x because you've already got an x and you only wanted an x. That's your answer. So when you're done, this should distribute to give you this. Let's see, 4x times 2x. Yep, that's 8x squared. 4x times negative 3. Yep, that's a negative 12x. So this should distribute to give you what you see up here. The other thing is you should never have a GCF in the parentheses. If there's a GCF in the parentheses, that means you didn't get the GCF out here. Okay, let's keep trying this. All right, looking at number 2. I'm looking for the greatest number that can divide into 5 and divide into 10. Well, it's a 5. What's the greatest amount of D's they both have? They both have 1. Okay, let's build our parentheses and figure out what's going to go inside, so when you distribute, you get this back. So what could you multiply 5D with to get a 5D cubed? A D squared. What could you multiply 5 with to get a 10? A 2. And then you don't need to multiply D with anything because all you wanted was a D. And that's my answer. Okay, GCF sometimes is really hard for students, so we just have a bunch that I wanted to practice. Okay, looking at number 3. Let's start with the 6, 12, and 24. Do you know what the greatest number is that can divide into 6, divide into 12, and divide into 24? Always start with the smallest guy. And sure enough, it is a 6. 6 can divide into all of those. Okay, what's the greatest amount of m's they all have? They all have 1. Okay, let's build our parentheses. Now, this time we're going to put 3 things in the parentheses because there's 3 things in the problem. Okay, so what could you multiply 6m with to get a 6m cubed? M squared. Okay, what could you multiply 6 with to get a negative 12? A negative 2. What could you multiply m with to get an m squared? An m. Okay, what could you multiply 6 with to get a negative 24? A negative 4. And then you don't have to multiply m with anything to get an m because you already have an m and you only wanted an m. That's our answer. Okay, let's try number 5. So starting with the coefficients. What is the greatest number that can divide into 4 and also divide into 10? It's not the smallest number this time. It's not a 4 because 4 can't go into 10. So what is it? It's a 2. All right, now let's look at the x's. What's the greatest amount of x's they both have? They both have 2. Now look at the y's. What's the greatest amount of y's they both have? They both have 1. Okay, let's build our parentheses and let's get it back. All right, so let's just start with the numbers. 2 times what makes 4? 2. Now look at the variables. X squared, they're a match. You don't need any more. Y, they're a match. You don't need any more. So that's all you need in the front. Okay, now the back. 2 times what would make 10? A 5. You've got 2 x's, you want 4 x's. How many more do you think you need? 2. You've got 1 y, you want 3 y's. How many more do you need? 2. And that's our answer. What do you think? It's not too bad, is it? Okay, let's try another one like that. All right, so starting off with the leading coefficients, 9 and 12. Do you know what the greatest number is that can divide into 9 and divide into 12? 3. 3 is the greatest number that can go into both. Okay, what's the greatest amount of x's they both have? They both have 2. What's the greatest amount of y's that they both have? 3. They both have 3. Okay, let's build our parentheses and get the original problem back. So 3 times what is 9? 3. Now look at your x's. Are they a match? Yep, so you don't need more. Look at your y's. Are they a match? Nope, so how many more do you need? You need 1 more. Okay, now let's get the guy in the back. 3 times what is negative 12? Negative 4. Now look at your x's. Are they a match? Nope, you need more. How many more? 2. Look at your y's. Are they a match? They're a match, so you don't need any more y's. So that's it. That's your answer. Okay, number 7. What is the greatest number that can divide into 2 and divide into 4? A 2. Now, do these both have an x? Nope. Okay, so this time the GCF is just a 2. Okay, let's build our parentheses. Now this one, students will mess up. These are a match, but I have to put something here because you can't leave like an empty spot. So 2 times what makes 2? A 1, and you have to put the 1 because there would be nothing behind it. So 2 times 1 makes 2. Okay, now what could you multiply 2 with to get a negative 4x? A negative 2x. So if I just distribute this out, let's see if we get this. 2 times 1 is 2, check. 2 times negative 2x is negative 4x, check. Okay, so that shows that you have to have the 1, so when you distribute, you get the original problem back. If I didn't put the 1, I would just have a negative 4x and not the 2. Okay, now this time, we have a 1 in front that you don't see. So the GCF of a 1 and a 4 is just a 1. Do they both have V's? They do. What's the greatest amount they both have? They both have 1. This time, our GCF is just a variable. Okay, so your V's are not a match. How many more do you need? You need 1 more. And then V times what would make 4V? A positive 4. And that's our answer, and we're done. Okay, let's do one more in this section, and then I have one other thing to teach you in this lesson. Okay, 6, 24, and 18. Do you know the greatest common factor of those? 6. What's the greatest amount of p's that they all have? They all have 3 p's. Okay, let's build our parentheses. Now we're going to have 3 things inside this time because the original problem has 3 things. Okay, so the 6's are a match. Are the p's a match? Nope. How many more do I need? I need 3 more. Now, if you wanted to put a 1 here, you can, because 6 times 1 is 6. The reason I don't have to put the 1 is because I have the p cubed. Okay, 6 times what is 24? 4. Now, are your p's a match or do you need more? You need 2 more. Okay, 6 times what is 18? 3. Now, are your p's a match or do you need more? They're a match. So that's our answer. Okay, that's the first little lesson today called the GCF. And every problem that you're ever asked to factor, this is what you're supposed to look for first. Okay, next thing up. All of these problems, just so you can see, down here, have 1, 2, 3, 4. 1, 2, 3, 4. 4 terms. Okay, so let me look back at this chart here. So we're always going to look for a GCF first, and then either it's going to have one or it won't. And then from there, we're going to look to see if it has 2 terms, 3 terms, or 4 terms. So I'm about to teach you how to do 4 terms, which is called factor by grouping. Okay, so these actually do have a GCF, like our last problems. It just doesn't look that way to students. It's kind of confusing. So I'm going to explain how it works. It's kind of strange, but this is how it works. Whatever is in the parentheses, it needs to look the same in order for it to be the GCF. If these don't look the same, then this problem is not going to factor by grouping. It's not going to have a GCF. So as long as these are the same, you're going to put it in a set of parentheses. And then whatever's left over, which is the guy in the front and the guy in the middle, that's what's going to go in the other set of parentheses. 3 minus a. And that's my answer. So if I was to distribute this out, let's just say I started back here. I would take 3 times the c and 3 times the d. Well, that's what this is showing you. 3 times the c and 3 times the d. Well, then I'd have to take negative a times the c and negative a times the d. And that's what this is showing you. Negative a times the c and negative a times the d. So this is what we do when the problem looks like this. So you want to see if the things in parentheses are the same. If they're the same, you write it one more time. And then you look to see what's left over. And what's left over is going to be the guy in the front and the guy in the middle, which is 6 plus y. And I'm done. Okay, looking at this one. I look to see if what's in the parentheses are the same, and they are. So I write it one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes in the other set of parentheses. 2 minus z. Okay, so looking at number 4. What do you think is going to go in one set of the parentheses? R plus 1. That's what they both have, so that's what's going to go in one set of parentheses. Now, the next question might trick you. What do you think is going to go in the other set? Mn minus 1. Remember, if you don't see the number in front, it's understood to be a 1. So it's Mn minus 1. Okay, so now I'm going to teach you how to get this original set up from the very beginning. Okay, so I've got a problem all worked out in the box for you, but sometimes when I go through the explaining of it, it confuses people. So let's just start one fresh. All right, so first you would look to see if there's a GCF to the entire problem. Can anything divide into 14, 21, 6, and 9? And there's nothing. Then you'd look to see if they all have x's, and they don't. So that means that there is not a GCF to the entire problem. So then I have to count if there's 2 terms, 3 terms, or 4 terms. And there's 1, 2, 3, 4 terms. So we're going to do this thing called factor by grouping. Okay, so I'm going to group together the front 2 terms, and I'm going to take the GCF out of them like I did on the previous page. So what's the greatest number that can divide into 14 and divide into 21? 7. What's the greatest amount of x's that they both have? 2. Okay, remember every time you have a GCF, you build one set of parentheses, and you're going to figure out what goes in here to give you these two original pieces back. So 7 times what is 14? 2. How many more x's do you need? 1. Okay, now get the guy in the back. 7 times what is 21? 3. Now, do you need more x's? Nope, they're a match. All right, then you group together the back two, and you take their GCF out. But I'm going to teach you how to cheat. So instead of taking their GCF out, let's do it this way. Remember how in the problems above, whatever is in this set of parentheses is what has to be here? So whatever you wrote here, just copy it here. Now you can easily figure out the GCF to these two because this times this should make that, and this times this should make that. So what could you multiply with a 2x to get a negative 6x? A negative 3. Now let's just make sure it works the whole way through. So negative 3 times 2x is negative 6x, okay? And is negative 3 times positive 3 a negative 9? Yep. Okay, so now I'm going to do what I did above. So whatever you have here and here, you write it one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes in the other set of parentheses. 7x squared minus 3. And that's how you factor by grouping. All right, looking at number 2. First, I'd look to see if there's a GCF to the whole problem. 1, 3, 3, 9. Nothing can go into 1 besides a 1. So if your GCF's just a 1, it really doesn't do any good typically. They don't all have a C. They don't all have a D. Okay, so there's no GCF. So then I notice there's 1, 2, 3, 4 terms. So every time there's 4 terms, I factor by grouping. So I group together my front two, and I take their GCF out. Do you know what they both have? They both have a C. That's it. That's all they both have, but they both have a C. Okay, build your parentheses, and let's get both of these back. What could you multiply with C to get CD? A D. What could you multiply with C to get a 3C? A 3. Okay, so then I could take the GCF out of the back, but I'm teaching you how to cheat here. Okay, so remember, whatever's in this set of parentheses, just copy over here. It can't look different, so never make it look different. And then backtrack. What times D would make a negative 3D? A negative 3. Negative 3 times D would make negative 3D. And negative 3 times 3 makes negative 9. Okay, so now I'm ready for my 2 sets of parentheses. Whatever you wrote here and here, you write one more time. And what's going to go in the other set of parentheses? C minus 3. It's whatever's left over, the guy in the front and the guy in the middle. So C minus 3. Okay. Oh, I just realized my example 3 is just like my example 1, but it has Z's instead of X's. Okay, I mean, that guess means we don't have to do it. All right, so this is how you factor by grouping. And that's all for this lesson. Smiley face.